Okay, we're ready to rig the head and neck of the character. And this is actually going to be a very simple rig, which is going to be based mostly on FK controls. Although we're going to introduce a slight IK-ish behavior so that the rig becomes more flexible in what it can do, and also some automated behaviors. So let's check out first the geometry we have to work with. So this is what we got. And we're going to have basically just 3 controls. One for the neck, one for the head, and one for the jaw. So I'm going to start by creating those 3 locators. Let's create this guy and match it over to the neck. Let's duplicate it and match this one to the head, and duplicate once more and match this one to the jaw. And let's rename them accordingly. Control center neck, control center head, and control center jaw. All right, and now let's give them display attributes that will be easier to use to identify each one of these. So for our friend here, we're going to use, for the neck, I'm going to use a circle. And it needs to be pointing on the x-axis. As you can see, x is running up. So let's make him smaller. Let's check. Yeah, that's overall okay. And just to make him easier to select, because we are really close to all the stuff on the torso, I'm going to move it up on X. Maybe there. And a little bit towards the back. Something like that. And we can make him actually a little bit smaller. There you go. Now let's do something for the head control. This guy, we're going to turn him into a sphere. And we're also going to move him up a little bit so that he is actually around the head area. And we can make him smaller. Like so. We can actually also scale him on the z-axis, just to make him a little bit narrower on the sides. Alright, and now for the jaw. For this guy, we need something that tells us that it's a control that is meant to be used for rotation. So I think I'm going to go again with a circle. And this one is going to be on the z-axis. And we're going to make him small. And we're going to move him onto the end of the joint. Somewhere around this area. Alright. Last thing that we need to do is color code them. So let's say that for our next circle, I'm going to use same blue we've been using so far for FK related stuff. For the head, I'm going to go with maybe a light green. And for the jaw, let's try something, well, no. Yeah, kind of like a violet kind of hue. Something like that. As always, we can change our minds later and use different colors. And now let's create the basic hierarchy for this. We're gonna just parent them like so. The jaw is gonna become a child of the head control, and the head control is gonna be a child of the neck control. And the neck control, we're gonna drag it over to the FK controls group locator. So he's gonna be in there. So now, when I grab my control over here and I rotate it, we can see everything comes along for the ride. And the other thing we're going to do is select everything, go to properties, and 0 all the transforms. So we can return to this state whenever we need to. Okay. So that's it. That's it for now. In the next video, we're going to start to rig this as an actual structure that will perform different functions on our character's neck and head area. So let's see you there. Okay, we're ready to rig the neck and the head of the character. And actually, this is going to be a very straightforward FK rig that we're going to do for these joints right here. And the only thing I'm going to add to it is an extra control to give the head some rotation based on the rotations on the neck control. And this is basically because if you observe the way your head rotates, you will see that the rotations on your skull are always connected somehow to the rotations on your neck. So what I'm going to do is that based on the rotations on the neck control, the head control and the head joint will also rotate a little bit so that we can have some of that rotation. And of course, this is going to have different values that the user can control so that he can determine how much rotation he actually wants, or even turn it off if necessary. So let's do that. I'm going to rig that here in the spine rig workspace. And the first thing I'm going to need is I'm going to need a new locator. And let's call him Locator C Auto Head Rotations. Okay, and I'm gonna set my drop action to insert, so I can insert it into a hierarchy, and I'm gonna drag and drop it onto the head control. So this inserts the locator in between. Let's find him here. Here he is, in between the neck control and the head control. Okay. So he's right there. If I rotate him right now, you will see that the head control is following along. So what we're going to do is give this guy some of the neck controls rotations. So let's select both and bring them over to the schematic. Okay. So here's the neck control, and here's the head control. So these guys' rotations are now tied to, well, they're not tied right now. We're going to do that right now. Let's add the rotation channels for the neck control. Actually, I can do it right from the channel list. The only rotation I'm not going to use in this case is the x-axis. We're just going to use the y and z-axis. So let's select those and remove them from the node. There we go. So now what I'm going to do is create a couple of math add nodes. So we're going to call this guy UTI head auto rotate value, and this one is going to be for the y-axis. And let's duplicate that node, and let's set this one to the z-axis. There we go. And of course we need to set some value on these guys. For now I'm going to set them to 1, and we're going to multiply this one by the rotations of the neck control. Okay, so we're going to need some math multiply nodes. There we go. Also a couple of them. So we're going to take the Y rotation and multiply it by this Y value, and then we're going to take the Z rotation and multiply it by this Z value, and let's make sure we're in setup mode, and let's wire these to Y and Z rotation for, oops, something changed there. Of course, what's happening is we have a value here that we're actually getting rid of, so that's why this is changing. So before connecting anything, this guy doesn't matter because it was 0 already, but we need to 0 everything, and now we can do our connections. There we go. So now that this is connected, you will notice that if I select the neck control and rotate it, we get that extra rotation happening with the head control, but it's because this new locator is actually taking care of that rotation. Okay. Now, this might be a little too much because actually you get a double rotation on the head control. It's rotating twice as much now, and that's because it's getting one full rotation value change from the neck control based on these controls, and another one is the inherited rotation because it's part of the same hierarchy. So that might be a little bit too much. So let's see how we can fix this. All we need to do is change this one value right here. Let's see how much this needs to be for this to work properly. So for example, for the Z-axis, we can make this easier if we rename this to front back, for example. Okay, and this one is going to be left right. That's just going to make it easier for us. So let's see, for this guy, I think the rotation needs to be a lot less than side to side. So for front back, let's set it to 0.4, for example, and for front back to 0.8. Not 0.8, but 0.8. There we go. And now when I rotate my neck control, you will notice that we get a lot less extra rotation. So that's good. Obviously, if the animator doesn't want this at all, he just needs to set these guys to 0. We're going to expose these as values somewhere later on the UI of the character. So all that's left is let's make this guy a lot smaller. Like so. And that's pretty much it. Now we need to constrain our joints over to their corresponding controls, and we'll be done. So let's take our neck joint and select the neck control, and let's do a I'll turn on compensation just in case. We should have no problems actually. Let's make sure compensation is off. If we do a rotation constraint, nothing should pop. If you see popping or something in your rig, it means that the control was actually not aligned to the joint, in which case you need to undo and make sure your control is aligned to the joint. Let's also make sure at the same time everything is zeroed. Yeah. Everything's okay. So now the head joint is going to be rotation constrained to the head control, and same for the jaw. There we go. So now let's grab again our neck, and you can see everything is working properly. It's all good. Okay, this is done. So that's pretty much the rig for the neck and head. So we can proceed with other parts of our character. So let's keep moving on. All right, so let's do, since we're working on this area of the character, let's get the eyes rigged. This is going to be a pretty straightforward and simple rig, but it's going to be nice to be able to animate the eyes of the character. So let's get on to that. the first thing I need to do is our geometry right now is not selectable. So we need to make it selectable again. So we just need to go to our Ace Geo group and make the members selectable. You could leave it at on or default. It's okay. Let's just leave it on for now. And now I can go back and select the geometry for the character. So let's see where the eyes are. Let's open up this group. And we're going to hide the body so it just becomes easier to work with the eyes. There they are. Now, one thing that is interesting is that in this case, both eyes are part of the same mesh item. So in some cases you might get separate meshes, and even their pivot points would be, their centers would be at the correct position for you to align a locator to. But in this case, they are both a single mesh item, and also their center is at the origin, which is actually quite common in most pipelines that you will find in professional studios. When a model is published so that the rigger can start rigging it, all of the geometry pieces have their centers moved over to 0, 0, 0. So that makes it easy to transfer assets in between files. But it means you cannot easily align stuff using the centers, as we've been doing with the joints, for example. You just match everything and things align. So we're going to find a different way of doing that over here with our character. And I'm going to show you how that would work. So we're going to need a couple of locators, one for each eye. And they're basically going to rotate. And the eye will rotate with it. And those locators are going to be pointing towards another locator that the animator will move to move the eye around. Okay? So let's get our locators in place for the eyes. So let's create a locator. And as you can see, he's down here. And just for you to see what happens, if I try to match this locator over to the eyes, well, nothing happens because, again, the center of the eye meshes is down here at 0, 0, 0. So what I'm going to do is going to switch to my front view, like so. And I'm going to bring up my snapping dialog and make sure vertex snapping is enabled. And that is because we are going to snap to this vertex right here at the center. That's where we want our locator to be. But snapping in 801 is actually very nice. It has a few features that are going to come in very handy. You'll see in a second. So first I'm going to take this locator and move it around so I can reach the eye. Okay, so let's grab our locator. Oops, looks like I grabbed something else. Yeah, I have the character locator. We want this one. I'll just move it up. And, well, I need to turn snapping on for us to see anything, and you will see it starts to snap to the vertices. So let's get the one right at the center of the eye. That's it. Okay, if we go to a perspective view, you will notice that, however, the locator is actually behind the eye, and that's because I moved the locator in sort of like a 2D space, so it snapped to that center point but behind it because the origin is behind the eye. So if we want to actually have the locator exactly at the middle of our eye geometry, we need to move it forward. And let's try that again. And let's move to our right view. And if you snap it to this vertex at the end over here, you will notice that in the perspective view, the locator is exactly at the middle of the eye. And that's because we snapped to the vertex here on the side, but since we were on a two-dimensional plane, our locator retained its center, well, its position relative to the center of the eye, which was the vertex we snapped to originally. But this is not what we want the locator. We want it in between these two edges, not rotating from here, but from the middle. So let's move it ahead a little bit, like here. Actually, we could try to use a different snapping option like edge center. So if I go back and move the locator, you will see it snaps exactly to the center of the edge right there. And in perspective, we're still at the center of the eye. So that's great. Snapping is a really great thing in 801. Let's make our locator smaller, just like more or less the size of the eye, something like that. And we're gonna call this guy CNS because it's gonna be constrained. You're gonna see that in a minute. This guy is the left side eye. Okay, we're gonna duplicate it. Let's go back to our front view, and we're gonna take the duplicate, turn back on snapping, but we're gonna use again vertex snapping, and let's move this guy over to our vertex here in the middle. Looks like it's not reading the vertex position. Yeah, I have snapping. Let's toggle it just to see if that helps. No, it doesn't. Well, if that fails, then what we'll do is take this locator over here and read its X position, copy it, and paste it onto the other locator, but as a negative value, because we know that the eyes are symmetrical. So there he is. He's right there in the middle. And we're going to rename him to our on the right side. So now that we have these locators, let's go back to our perspective view. We can turn off the snapping, and we're going to give them targets to look at. So we're going to take both, duplicate them, and we're going to rename the duplicates. So one is going to be CTL for control left eye, and the other one is going to be CTL again, RI. Well, let's take these controls and move them in front of our character. Okay, let's unhide for a second our body mesh, and let's make sure that the eye controls are somewhere where they can be easily grabbed and distinguished, but not so far that they are not so close either to the eyes, not so far. I guess somewhere in there it's okay. And to make it a little bit more obvious that these are the eye controls, I'm going to change their display shape to a circle. And they're going to be looking on the z-axis. That's fine. Let's just make them smaller, like so. Something like that. Okay. Now what we're going to do is constrain our locators over to these guys. But before doing so, I'm going to make these locators a child of our head bone, our head joint over here. So we're going to take everything, go to setup, compensation on, parent in place. So now these guys are children of the head joint. So whenever the head joint rotates, they are going to rotate with it. Okay, good. Now let's constrain them. So we're going to take the first one, this guy, and constrain it to our locator over here. And as you can see, he's looking down the z-axis, which is okay. So let's just go turn off compensation and use a direction constraint. So he's constrained. And let's do the same with the other one. There we go. So now if we take the control locator and move it around, you can see the locator that is behind the eye rotating. Okay. Now we're gonna add another locator that is going to control these two, because right now we have independent eye movement, one control for each eye, but in most cases you would want to animate both eyes at the same time. So let's add another locator. For now we're gonna match it to any of these two controls. That's okay. And then we're just gonna move it on X to 0. So it's between both. And we're gonna call it control center eyes. Okay. And let's change it to display properties. We're going to make him into a plane. And let's make him small. Kind of like that. And smaller on the y-axis. Alright. And now we're going to take both eye controls and make them children of this eyes control. So now when I grab this guy and I move him around, you can see both locators in the inside of the head rotating to look at it. And one thing we're going to do is create some transform spaces for this control and for the head control. We're going to do that in the next video. I'm going to explain to you what that is and how that's going to work. For now, it looks like our eyes rig is already done. All that's left is to get the eyes to actually move with the locators behind them. We're going to do that very quickly. Let's hide the body again. So what we're going to do is take these guys, and we're going to need to rig this somewhere. So we could probably do that on the we can do it on the spine rig workspace. So let's take again our eye meshes. We're going to add them here. And we're going to use a couple of weight containers to do this. Okay. So let's go to our deformers. And I'm going to go into Vertex component mode and select all the vertices on one side. And I'm going to create a container and add the selected points. Okay. So if we check our weights, you'll see that everything is at 100%. So now let's select, if we double click on this guy, you can see that the first container is there. Let's actually rename it since we're at it. Weight container, right eye. And now let's select the vertices, oops, on this guy on the other side. And let's also add another container. Let's check its weight. Everything is already at 100%, so that's good. And you'll see that this container is already added in here. And we're gonna rename it to weight container left eye. Okay. So that's good. And now what we need to do is let's add some transform effectors to these containers that we are going to use with these locators over here. So let's grab the locators, the constraint locators, and add them to the schematic. There they are. We're not really interested in the constraints at this point, so we can hide them. That's good. So this is for the left eye, this is for the right eye. And now we're just going to select the first container and add a general influence. Okay, let's go to setup mode. And let's select the other container and add also a general influence. And now we just connect the locators as the effectors that we're going to use to drive the deformation. So there's one, there's the other. Okay. So let's get out of setup mode and see what we have. Let's grab one eye control. There it is. Our eye is moving. Let's grab the other locator. The other eye is moving. And let's graph the eyes control. Both eyes move. So looks okay. Let's see if everything looks as fine with the mesh of the character displayed. Everything looks fine. So we're done. The only thing that's left is obviously to zero out our controls. So let's take all these guys and zero everything. And we're done. This completes the rig for the neck head of the character. So in the next video, we're going to work on some transform spaces for both the head and our eyes controls, and I'm going to explain what that is and why we're doing it. By the way, you can color code these guys any way you want, so that they're easily distinguishable and identifiable on the animation workspace. Okay, I'll see you in the next video. Okay, so let's talk about the transform spaces for our eyes control. What do I mean by transform spaces? What I want the eyes controls to do is to be able to take a different parent space depending on different parts of the character, and I'm going to show you why. Let's hide the character's body for now, so you can more clearly see what's going on. If I take the character's head control right now and I make it turn, you will see that the eyes are not following the head. They still point forward. And that's perfectly normal. That's as expected because the control for the eyes hasn't moved. It's here. And these guys are constrained to point this way all the time. So what we need to do is I want to be able to tell the eyes control to either stay fixed in space, because sometimes you want to, no matter what you do to the body of the character, to the eyes be fixed in a location in space. But I also want to be able to make this guy follow the rotation of the head control so that the eyes can follow around. So we're going to create a little rig that is going to enable us to do both of those things. So let's go here, and the first thing I'm going to do is let's go into setup mode. I'm going to create a locator, and I'm going to match it over to this guy's position. Okay, and let's change the display on this locator. We're going to make him into a nice little box right there at the center. And we're going to call him CNS Center Eyes Transform Space. Okay. All right. And we're going to take our eyes control and parent it to it. So now this guy will determine where the eyes go. And this is going to be, for now, we're going to use two transform spaces. One for the head and one, in this case, for the shoulders. I'm going to change it very likely later because I don't want the eyes to move when I move the shoulders and the head stays fixed. That's going to be, it makes no sense. But for now, I'm going to leave it here because we're not done with the rest of the rig of the character. So let's create a couple more locators. You will need one per parent space that you want to create. It doesn't really matter how many these are. That's going to be mostly up to your needs or the needs of your character. Let's just match them to the same location than our cube there. And we're going to call this one Locator Center Head Space. And we're going to duplicate it and call the second one, for now, Shoulder Space. Okay, and we're going to parent each to their corresponding control. So we're going to parent the head space to the head control. With compensation on, we parent in place. And now we take the shoulder space. And before we do that, let's find this guy here in the items list because we're going to need him. There he is. And now we take the shoulder space and parent it over to the shoulders control in place. And let's go find those guys. Here they are. Okay. And now what we're going to do is we're going to tell the our little constraint item over here, which actually it's not gonna be constrained, but I'll just call it that way, to follow either of both. So let's take the shoulder space, the head space, and the eyes transform space and add all of them to the schematic. And we're gonna take this guy. He's gonna be the one blending in between these two guys. And to do this, instead of using our constraints, we're just gonna use matrix blends. So let's add the world position matrix, and let's add the world rotation matrix. And we're gonna add a math node that we're gonna use to make this the blend value. So let's call it UTI center eyes transform space blend. Okay, and now let's add a couple of matrix blend nodes. One right there. Let's duplicate it. Okay, and we're gonna plug the world position of the shoulders and the world position of the head into one node, and then same thing for the rotations. Okay, so we get something like that. And now we need the blend values for these guys, so let's add the blend channel. And now let's plug our matrix outputs. This guy is the blend for the position, and this guy is the blend for the rotation. And let's plug here our blend values driven by this math node, which right now it's set to a value of 0. We have something interesting here happening. As you can see, what's happening is this control has an offset between its setup state and the actual scene state. So let's see where he is. He's up there somewhere. So all I have to do is, the setup state is correct. That's what I want. So let's just go here, grab him, and match it to this control. Oops. Sometimes I get that warning, but that's all we needed to do. So now everything is correct. So now let's see how the rig works. Okay. So everything is going to be dependent on this blend value. Let me show you. With the value of 0, if I rotate the head, the eyes don't follow around. They're looking to the front because they're weighted towards this first node, which is the shoulder space. Okay. And if I set the value to 1, then as I rotate the head control, the eyes follow along. Of course, you still have the ability to animate the eyes manually by using the eye controls. So that's not affected. I can actually also do it over here. And since it's a blend, well, basically just blend from one transform to the other. And that's it. So that's pretty much all we want to do for our rig over here. Let's set everything back to its normal state. Let's make sure that our controls are properly zeroed. This guy's zeroed. This guy's zeroed. This guy now has this offset that we introduced, so let's zero it out. There we go. And we're good. So all that would be left would be to let's name our stuff properly, those matrix blends. Let's call this guy matrix blend. This one is for position. We can get rid of the C if we want. Eyes control. Let's say eyes control position, and this guy is going to be matrix blend eyes control rotation. There we go. And the transforms also, I renamed them earlier. These are kind of important because they're deformers, so we want everything in our deformer list to also be clearly labeled Otherwise, later on, we're not going to have any idea what we're dealing with. So that's it. And that's it. This is it. This is the rig for the eyes. So everything is pretty much working now. Of course, we're going to have to later take care of all this and clean up our workspace. But we're going to be doing that in the next few videos. So let's keep going.